Hello guys, today we are going to look into the async code in JavaScript, how asynchronous code works and why it is needed, and how we can use this. So we'll see all of this one by one and we'll start looking at it. For an example, in JavaScript, we use set timeout. That is one of async uh, construct we have. And for example, I just have written this set timeout where I'm consoling something after 1000 millisecond, and we have this console.log statement along with that. So if we run this, so what happens is, okay, let me run this before. So first we see that I am synchronous execution got printed, and then this is async execution that got printed, because here we had delay. So obviously we'll think, okay, the first thing will be printed is this, then after delay we'll print this. So that's what happened here. But some point to be noted here is, even if we try to change the displayed message, this message is, if you try to change this or the time provided by us, if you change that as well, even if I put 0 here, 0 millisecond delay, the async message will be displayed. This async message will be displayed only after the sync message. This is because any function given to the set timeout function will be executed asynchronously when the main thread is not busy anymore. So what I'm saying is, our main thread will be executing all the synchronous code. So the first thing it will encounter is this, it will execute this, and this set timeout, set intervals, and other thing which we'll see later on will not be executed by main thread directly. Rather, it will be taken up by the queues, and it will wait there, and once the main thread is free, it will take out the next piece of code from the queue, and it will put in the stack that the main thread, and then it will execute that. So even if you put it as 0, that doesn't mean that it will run immediately. It will, because it has to go through the async code mechanism, and that's the reason. Even if I omit 0, if I omit this completely, and I'll put I'll put some more example. Let's say what I can do is, I can just have this a console statement, a for loop, then again a console statement, and this function which I'm calling inside this for loop. So what should be, first I'll clear the previous console, and if we see this here, we are not giving any delay. This is async code, we are just consoling it. The first one is asynchronous code. This for loop is again a synchronous code. This console is a synchronous code. This is a function which depends whether who is calling this, and as we can see, for inside for this is getting called, so obviously this will be called synchronously. And if we print this, so what should be the order? So ideally we should think that this should get printed because there is no delay. Means we have not defined, not we haven't even given 0, we are not giving any delay, so it will get printed immediately. But no, that's not correct. The first thing that will printed is console.log statement. First let's run it and then I'll explain. So first we are seeing that test1 is getting printed because it is sync code. Then for loop will get executed 10,000 times, and it will keep on calling this do some stuff where it just uh, returning 2, and this will get called again and again, and this will keep, because this is an expensive operation, this will keep main thread busy, and until unless this main thread is have not executed this completely, it will not execute this line. And so once this is completed, then we'll see test2. That's what we are seeing here. And once that is also complete, then we don't have anything to run after this, and we will then execute this async code through the mechanism I've already explained. It will come from the queue to the execution stack and will be executed by the main thread. And but yeah, this was an expensive operation, so there would have been a delay between test1 and test2. But yeah, that is due to this expensive operation, not because of async nature. This all of it is it's a synchronous code. There is no async mechanism involved here. Only async thing here is set timeout, which will run only after all of this thing is completed. So even though we haven't given any timeout, any delay here, means it's 0, but still due to this expensive operations, this guy is getting executed much later than what we expect because we are not giving any delay. I'll run it again and see that you'll find some delay. It's not that evident if we'll make it 10,000 to maybe 10 million or something like that, then we'll see some delay, but yeah, that's what that happens. So there are, and we got some learning from here. And as I've written here, the IM asynchronous message will be displayed when main thread reach here. So main thread will reach here when it will execute all of this line, and then it will print this. This is asynchronous execution. So this is the way async code works. And what learning we can have from this: simply never trust the delay given to the set timeout function. Set timeout function, whatever delay we are giving, never trust that. That doesn't mean that after that delay it's going to execute for sure. That is the minimum delay. We can only specify the minimum delay. We guarantee that okay, this much time is passed, then only our this piece of code will get executed, but that is the minimum time interval we can think of, not the exact one. It can even go beyond that. And even if we set zero delay, our code will be executed much later. So now, taking some another example, we'll take a example of the set interval. uh, we'll take example of set interval. So we have this counter variable 0, and we have this set time interval where we have given 1,000 millisecond delay between each of the execution. And inside the set interval, what we are doing is we are consoling something. We are incrementing the counter, and if counter reaches greater than 5 or equal to 5, the value of counter reaches to 5 or more, we will clear the interval. Because what happens, set timeout will execute once and it will be killed. It will no longer be there and it will go out of the execution. But set interval will keep on running until unless we clear it. So we'll have to specifically clear it using clear interval function. There we need to give the timer associated with our set interval. So how we get that timer? So whenever we instantiate that set interval, it returns a timer. It is some ID, and we can call clear interval function and we can give that timer or ID, and it will clear that particular instance of set interval. So that's the only way we can clear the set interval. Otherwise it will keep on running forever. So we are making sure here that once the counter value reach 5 or more, we'll clear the timer and it will not run. And after this set interval, we have this code console.log I am asynchronous message. So the behavior is same as set timeout. So this is async code. So we know that first thing which that going to be printed is this I am asynchronous message. And let me comment out all of these things because I don't want to run it again. We are interested in this example right now, and let me run it. So what happened, first we'll see this message, then we'll see this message 5 times. I'm asynchronous, and look, the other messages are printing after interval of 1 second, and we are seeing this 5 times. So this was again an example of the async operation in JavaScript. So set interval has the same behavior as the set timeout, but the code is executed multiple times. We have to call clear interval to kill the timer. Set timeout and set interval are the only native functions of JavaScript to execute code asynchronously. However, if you are familiar with JavaScript, you have probably dealt with asynchronous execution in various forms. It can happen in multiple situations. So some examples like performing an HTTP request. Second is input output operations when we are in Node.js environment. Third is WebSockets, whenever we use WebSockets, be it client or server side. All of those is again an example of async operations in JavaScript. So some examples, and now we'll comment out this. Sorry. And I'll give you one example of the input output operation, the file read operation that happens in Node.js. If some of you are familiar with Node.js, we have this fs. Through fs we can read any file. We can just give that file name and it gives us a callback. In the callback, if there is no error, then we get the content of the file and we are just printing it here. The data, this callback have some values like error and data. Data is the content of the file, and we are printing this line asynchronous message content of text.test, that is data. So the first thing is going to print it is synchronous message, then we'll see this thing getting executed and we'll see the content of the file. Since we don't have any file here, so this executing this line will not print us anything. Just for example, I am stating that this is one of the async code of async code example for the input output operations. Now, thing what comes to our mind is, why do we need this asynchronous code execution? What is the benefit of this? So asynchronous techniques are very useful, particularly in web programming. And when we deal with JavaScript, so we are basically working in web programming, and it is very beneficial. When a web app runs in a browser and it executes an intensive chunk of code without returning control to the browser can appear to be frozen. This is called blocking. You may have seen it that sometimes your web page become unresponsive. That is because your browser is not getting control of the processor. There is some process which is using the processor and it's not passing the control of the processor to the browser, and browser, because it's not getting the control of the processor, it can't process your input, like you can't interact with the page anymore. And so this is one of the example where blocking happens because some expensive operation is using the processor and it's not passing the control to the browser. So browser is blocked from continuing to handle the user input and perform other tasks until the web app returns control of the processor. So for an example, if I'll create a button, 1 second. If I create a button, I add a event listener, the add event listener, which is the click. So whenever somebody clicks on that button, what we are going to do is we are calculating the date. We have this myDate variable and we are looping this for 10 million times and updating the myDate variable. And this is very expensive. I'm saying this is very expensive. So on clicking of that button, this piece of code will get executed for a longer duration and the main thread will be busy calculating the date. Once this for loop will complete, then only execution will come to this line and main thread will be consoling myDate. Once that is done, we'll create a paragraph element and we are putting this text that this is a newly added paragraph, and then we are putting this paragraph into the body, and then in the body we'll see that paragraph. So but this clicking on this button and creating this paragraph will take a long time because the calculation part of date it's taking very long because we are doing a heavy calculation here. This is not a practical example, but yeah, an apt example to tell you that some of the operation which is very expensive will keep hold of the control of the process and it will not pass the control of the processor to the main thread, and due to that our web page will appear frozen. So here when running this example, we open the JavaScript console and then click the button. We'll notice that paragraph does not appear unless we get the dates calculation finished and we console the message. Only after that we'll see web page having that paragraph. This code run in the order it appears in the source, and the later operation doesn't run till the earlier operation has finished running. Means once this code is finished, then only we'll get this particular thing, this getting executed, and then this getting executed. Will not get this paragraph appeared in the page first, then we do this calculation. Whatever coming later will appear later because the earlier operation is still not finished. That is an expensive operation. So that's what I was trying to explain. So before going deeper into this, we'll first try, because I was talking about thread processes, and also we'll try to understand what is a thread. Thread is basically a single process that a program can use to complete task. Each thread can only do a single task at once. It can't do multiple tasks at once. So what happens, a thread will be doing a task, let's say task A. Once that is done, then it will do the task B. Once that is done, then it will do the task C, because each of the tasks will be handled by a single process. A single process can execute a single task at a time. So those tasks are to be executed sequentially. There is no way it can do it in parallel. Each task will run sequentially. A task has to complete before the next one can be started. So once the first one is finished, then only next one we can start processing. As explained earlier, many computers now have multiple cores, so we can do multiple things at once. Programming languages that support multiple threads can use multiple cores to complete multiple tasks simultaneously. For example, Java is one such programming language where we can do multiple tasks at once. Like one thread 1 will be doing task 1, task A, thread 2 will be doing task C in parallel. So this task A and task C will be executed in parallel, and once task A is complete, then task B will be picked by thread 1. Once task C is complete, task D will be picked by thread 2. But this can only happen in a multi-threaded programming languages like JavaScript, C Sharp, etc. Now coming back to JavaScript. JavaScript is a single-threaded. JavaScript is traditionally single-threaded. Even with multiple cores, we could only get it to run task on a single thread called the main thread. So here there is only a single thread present, and that is known as main thread. Earlier example what we saw, main thread will be doing dates calculation first. First the date will be calculated, then it will console the message, and then it will display the paragraph in the web page. So this is how main thread gonna take care of this example what we just stated. And since there is a single thread, so first the dates calculation will be done, and it has the console message will have to wait for this, and then display paragraph has to wait for both of these things to complete, then only paragraph will be displayed on the UI. Until that time, browser will not able to take any user input, or it can't process anything in between. It has to wait for other things to get completed. So another example is, let's say we have two tasks, task A and task B, and main thread first will be doing task A. Once that finishes off, we'll take task B. In this case, task A is doing something like fetching an image from the server, and task B then does something to the image like applying a filter to it. So first we need the image to be downloaded, and then only we can apply a filter to it. So this task B is dependent upon task A. Until unless task A finishes off, we can't run task B. If we run task B even before task A has completed, it will throw an error. So if we start running task A and then immediately try to run task B, we will get an error because image won't be available yet. To fix such problems, browser allow us to run certain operations asynchronously. Like we can run this operation asynchronously. We can run this operation asynchronously, task B, once the task A finishes off. So we have features like promises or callbacks, which allow us to set an operations running, that is fetching of an image from the server, and then wait until the result has returned before running another operation. So what I mean to say is, we can run the task A, wait for it to get finished, and that once that is finished, then we can run the another task. So for an example here, if we have this main thread running the task A, and we are using promise to resolve, we'll wait till task A finishes off once, because it's an async operation. So we'll wait using promise, and once this task A is finished, we can go and run the task B. We can use promise or callback, both will be okay to use here. And one thing to be noted here is, task A is downloading the image, and till the time this download is being happened, our main thread will be doing something else. It won't be kept waiting for the download to be completed, and else main thread will be busy here, though it's not doing anything, it's just waiting. So that's the benefit of the asynchronous programming, that if some operations like HTTP call, some download, or some input output operation, or some WebSocket thing is happening, it can be taken care by promises or callback. But in the meantime, main thread will go out from the execution, and it will try to execute something else in the synchronous order of the code, and it will come to this portion, async operation part of the code, once the task is finishes. In our case, once the task A is finishes, the main thread will come here, and then main thread will give the execution, the control of execution to this async operation, and then task B will be executed following this async operation. So that's how things happens. Since the operation is happening somewhere else, the main thread is not blocked while the async operation is being processed. It will keep on doing something else in between, for the reason we have explained before related to the blocking. Many web API features now use asynchronous code to run. For an example, when we use an API, when we call an API, there is a web API. The browser have some web APIs for HTTP call, and it will be handled by that, and the main thread will be doing something else in between. And once that thing it's completed, means let's say the API call has finishes up, then only it will come to the main thread. So this is how we work with async code. And some more example like fetching a file from the network, accessing a database and returning data from it, accessing a video stream from a webcam, or broadcasting the display to the VR headset. These are some of the example where we are dependent upon the external source, and our browser API will handle these scenarios. Once we get the actual data and the wait is over, then only our control of execution will come to the main thread. So why is this difficult to get to work using asynchronous code? Let's look at a quick example. When we fetch an image from a server, we can't return the result immediately. That means the code, the earlier one what we were seeing will not work. Let's say for an example, if I quote here, first we'll fetch the image, which will be a asynchronous operation, and then we'll get that in the blob. But this thing will not happen immediately. This fetch will not happen immediately, and if we run it synchronously, we will end up doing response.blob, and response now is nothing, because until unless this fetch completes, then only we'll get the response, and then only we can do this response.blob. So instead, what we need here is that's we need our code to wait until the response is returned before it tries to do anything else to it. So there are two main types of asynchronous code style we will come across in JavaScript. There is an old style callbacks and newer promise style code, and we will see each of them one by one. First, we'll see the async callbacks. So async callbacks are the functions that are specified as argument when calling a function. So what happens? We are calling some function, and in the function we pass another function as a argument. That is what callback is. Callback is nothing but callback is a function which is being passed as an argument inside another function. I'll again repeat, async callbacks are functions that are specified as a argument when calling a function which will start executing code in the background. When the background code finishes running, it calls the callback function to let you know the work is done. An example of async callback I can give you is the event listener, what we attach to a button. If we do something like this, there is a button btn and we attach an event listener to it, and that's the click. What we are doing, we are giving a function. If you see, the second parameter is a function, and the second parameter is a callback, basically because it's a function when passed as an argument is nothing but a callback. So here this click event listener have this callback which is highlighted by me, and this will run only when the button is being clicked. So when button is being clicked, as a response for that, we will call this callback. And the first parameter here is type of the event to be listened for. So here we are listening to click, and the second parameter is a callback function that is invoked when event is being fired. When we pass a callback function as an argument to another function, we are only passing the function's reference as an argument. Here what I have been highlighted, this function's reference is being passed. We are passing the function's reference as an argument, because you know in JavaScript functions, arrays and object are being passed as a reference. So here also this function is being passed as a reference in the argument. That is, the callback function is not executed immediately. Just the reference is being passed. We are not calling it immediately. It's not being executed immediately. It is called back, hence the name. So it is called back. It is called back later on, and that is why we call this function as callback function, because it is called back after some time, and it is called back asynchronously somewhere inside the containing function's body, and the containing function is the responsible for executing the callback function when the time comes. Another example what I can give you is making an HTTP call to the server, and there also asynchronous programming comes into play, because when we make a call to API, we'll have to wait for it to fetch us the result, and look how that happens. So we have a function called load asset, and here we are creating an instance of XML HTTP request, and we are passing some parameters like URL of the API, what is the type of this XHR response, and on load we are calling a callback, and in the callback we are passing the response what we got from this API. So this API what we are calling, this is XHR is nothing but an object of that XML HTTP request. We are passing this URL to get the result from this URL, and we get the response, and we are this onload function, this xhr.onload will get called only when we get the response from this API. And once we are inside this block where I am highlighting, we get the response. Here the response is present. So that means we can do whatever we want. So we are running a callback which have been passed as a third parameter in the load asset, and we are passing the response to this. And at last here we are sending the HTTP request. We are making the API call actually here. And now see how we are calling load asset. Load asset, we are passing the URL, that is nothing but coffee.jpg. What kind of thing it is? It's an image, so type is blob. So type is being passed as blob. The third thing we are passing is a callback. Callback means it's a function being passed as argument. What is that? Display image, and display image is this function. And as we can see, we are calling this callback, that is nothing but that display image. We are passing the response, so that response will actually come here as blob, and we are creating the URL, we are creating the image element, and then we are attaching the image element in the body, and then in the web page we'll see the image. So that's how we are making an API call. We are waiting for it. This onload will get called only once the API has downloaded the image. Till that, the execution will not be here. Main thread will be doing something else. It will just call this load asset, and it will call this xhr.send, and then the control of execution will pass to the main thread, and main thread will be doing something else, some asynchronous code which is in line. It will be executing that. Once main thread is free and also this onload function is being called and we have the response, then our callback will be run, and callback will create an image element and attach it to the web page, and we'll see that image. That's how the callback works. And one thing to notice is not not all callbacks are async. Some run synchronously. An example is when we use array.forEach to loop through the items in an array. For an example, if we have a gods array and we are looping through gods array using for each we are passing a function, so then again it's an callback, but this callback is not an async callback. This is sync callback, means it's running synchronously. So that is the point to be noted here, is not every callback is async. Callback can be async, the callback can be synchronous as well. It's not always true that callback need to be async. Only in our case here, display image, this was a callback which have been run asynchronously because of the nature of API calls. But in this example of for each, this is a synchronous callback. So okay, now coming to the promises. So promises are the new style of async code that we'll see in the modern web APIs. A good example is fetch API, which is basically like a modern, more efficient version of XML HTTP request. So here we were making the XML HTTP request, and the fetch is something which is modern and the more advanced version of making XML HTTP request. We can have one example to look how we use fetch API. So fetch API is available in the browsers, and what we can do is in the fetch, we can give a URL to it, and it returns this fetch. On giving the URL, it returns a promise. Promise is nothing but an object, and this thing which I'm highlighting is returning an object, and that object is nothing but a promise. And to use promise, we have to use then. We will see how we can resolve a promise. There are some ways like using then or async await. Async await we'll see later on, but for now, to explain the promise, we'll not dig deeper into this then or async await thing, but just understand this, that fetch is nothing. Fetch is just doing an XML HTTP request call. It's calling this API. We have passed the URL, and dot then is the way to resolve a promise. So dot then is a function which will resolve the promise, and here we are passing a callback which will run once we fetches this API response, and from here we are returning response.json because we are transforming the response to a JSON format and we are returning it. Whatever we are returning from here will again become a promise, and that is why we are again doing dot then here, and here we are getting that JSON valued response, and we are keeping it in a variable called products, and then we are calling some function called initialize, which we don't have here. We are using product there. And beside that, we have a catch block as well. Catch is if something happens, something bad happens inside any of the then block, or our promise is rejected. If our promise is successful, then we'll end up in then block. But if our promise is not a successful and it is rejected or errored out, then we'll come inside the catch. And in catch, we'll get the error message, and we can just console that, okay, this is the problem while fetching this API. So this is how fetch works, and fetch returns us a promise. That is why we are using dot then to resolve that. From the then block here, we are returning something, and that again becomes a promise. That is why we are using then again. And here we are just calling some function. We are getting the values of the product, and then at the last we have catch in case we end up having some issues. So here we see fetch taking a single parameter, the URL of a resource we want to fetch from the network, and it returns a promise. The promise is an object representing the completion or failure of the async operation. So point to be noted here is promise is something which will either fetches the value, it can be a success, or it can be a failure. So either it can be a completion or a failure of the async operation, whatever async operation. So what async operation we were doing here, we were calling an API to get some value. So it can be a failure, like maybe network goes out, then it can be failure, will end up in the catch. But if not the case, everything is fine, then we'll end up inside this then. So it represents an intermediate state. Promise is nothing but it just represents an intermediate state, as it were. In a sense, it's a browser's way of saying, I promise to get back to you. I'll come back to you with the answer as soon as I can. Right now, I can just promise you, okay, I'll get you the value. I promise you that, but I'll come back with the answer as soon as I can, whenever I can. I have some clarity whether I can get you the value or there is some issue. That is why the name is being coined as promise, because your browser is kind of promising us to get us to the value. Neither of the possible outcomes have happened yet. Right now, when we call the fetch, neither the failure has happened, neither the success has happened, but we got the promise, because in some point of time we'll get the value for sure. So the fetch operation is currently waiting on the result of the browser, trying to complete the operation at some point in the future. In the future, not now. We have then got 3 further code blocks chained onto the end of the fetch. So we had 3 code blocks chained: the first then, the second then, and the catch. The 2 then blocks both contains a callback function that will run if the previous operation is successful, and each callback receives an input. Each callback receives an input. The first one receives response, the second one receives JSON, and so we can go forward and do something else to it. So once we get this value like response, we can do something from here, right? Then we got JSON here, then we can do something from here, because we know that we got the value. We are inside this, means we are having the value. Each then block returns another promise, meaning we can chain multiple then. So it means that we can chain multiple then. Here we have chained 2, and each then is returning a promise, right? So these are the some of the things which you should always keep on mind, and once we progress with our lectures, we'll try to understand it more. And these are the some of the nuances of the promise which like people forget, and then they make mistakes. So multiple asynchronous operation can be made to run in order one after another. And this is a nice way to handle the multiple async operations using promises. The catch block at the end runs if any of then blocks fail, in a similar way to the synchronous try and catch. We have seen in asynchronous codes that we have a try and catch. So whenever something happens, something bad happens, some error comes inside the try block, we go into the catch. It is very similar to that, but yeah, it's not same. This catch is not same as try catch, but it's similar to that. So an error object is made available inside the catch, which can be used to report the kind of error that has occurred. Note, however, the synchronous try catch won't work with the promises, although it will work with async await, and we can look into the async await later on. Right now, we'll just keep our lecture till here, and we'll try to look into the callbacks more, and what are the some pitfalls of the callbacks, and why we are using the modern day promises in the next lecture. And then we'll look into more into the promises and the some common mistakes which we make while using the promises. Also, then we'll look into what are the various ways to resolve the promise, like then and the async await. So till then, I'll just say goodbye to all of you, and people do subscribe to my channel. I'm seeing that you people are coming to the channel, watching the videos, but you people are not subscribing to it. You'll miss out on the important lectures and notifications. And if you like the video, please like it. So till then, bye guys.